Rihanna wants. So all right, guys. Yeah, I need to call Rihanna to see if she wants to, collaborate again. Rihanna and I are buddies. But okay, so let's go ahead and start. Area under the curve, FTOC. So we're looking at this, and I want the shaded region. If you have one of those fancy printers, it's going to print out light blue. If you have I don't have fancy printers here at school, so my printer, it came out like light grayish. Um, so yeah, so if I wanted to find the area of this shaded region in blue, I would probably do, let's see, I have two equations. It's a piecewise function. I would probably go integral from 0 to 1 of x squared dx plus integral from 1 to 2 of that linear line, 2 minus x, close it, dx. Notice I put parentheses on that one. Sometimes mathematicians will not put parentheses. So if you see 2 minus x like that without parentheses, relax. It's still, the function is still 2 minus x. It's just that it's proper to write parentheses, but some mathematicians don't do it because it's supposed to be like the sum of width times height, because the dx is like a width and the 2 minus x is like the height on the y value, because you're summing up an infinite amount of rectangles, if you remember that. So there it is. Those are my integrals that will give me my answer. So let's see if we can figure this out, guys. Antiderivative of x squared, that is x cubed over 3. But because I have all this stuff over here on the right-hand side that I haven't evaluated yet, I'm going to put a bracket on this, and I'm going to put a 0 and a 1 on the 0 on the bottom left right-hand corner, 1 on the upper right-hand corner, plus, and then I'm going to do another antiderivative, and I'm going to put another bracket. Antiderivative of 2 is 2x, minus antiderivative of x is x squared over 2, and I'm going to close this bracket, and I'm going to put a 1 and a 2. 1 on the bottom right, 2 on the upper right. So here's the correct way to write all this stuff, like to put your thoughts together. So be careful when you're expanding stuff and you're like, oh, this is evaluated here, this is evaluated there. So there it is. That's where I'm going to evaluate. And here it is. We're going to go ahead and do the math. So I'm going to put an equal sign, and I'm going to see, let's see, I'm going to do this part, the x cubed over 3 first. So I'm going to go, let's see, bracket 1 to the third, so that's 1 over 3. 1 to the third power is 1 over 3 minus 0 to the third, so 0. So there it is. I guess I didn't need a bracket there. Plus bracket parenthesis. Let me do upper minus lower. 2 times 2 is 4. Minus, that's not the minus of the, top minus bottom. That's that minus there. 2 squared is 4. 4 divided by 2 is 2. So 4 minus 2, close parenthesis, minus, now I'm doing the lower one. 2 times 1 is 2. Minus 1 squared is 1 divided by 2 minus a half. And I don't think we need a calculator, but let's see. So I have 1/3 from here. Plus, let's see if we can do this. 4 minus 2 is 2. 2 minus a half is 1.5. I'm going to put 1.5 for now. 2 minus 1.5, that's a half. So it's 1/3 plus a half. Common denominator, I'm going to multiply this by 2 over 2 times 3 over 3. And let's see what we get. So we get 2, 6 plus 3, 6. So we get 5 over 6. And there it is, guys. That's my answer. What's up? No, this is the exact. This is the exact area. Now, maybe you're thinking, Chavez, you did way too much work for this. I see a triangle for the second half. I didn't want to do all that mumbo jumbo. Can't I just find the area of that right triangle there between 1 and 2? Yes, you can. We should have gotten, let's see what that is. That should have been a half, because that's what the right side gave me. All this is a half, right? So let's see. The difference between 2 and 1 is 1. And that's height is a 1. 1 times 1 is 1, and divided by 2, OMG, it's a half. So whenever possible, if you see something that is geometric and you don't want to calculate all this integrand, go ahead and do that. Find the area with geometry. Cool or not cool? Okay. Look at question number 2. I'm going to see if I can do it in a neutral color. Notice that question number 2, they want this region here shaded up there. I have a rectangle, and then what I'm going to do is I'm going to find the area of the rectangle. So area of the rectangle, the height is 2 and the width is pi. So area of all of this, the whole rectangle, the whole shebang, is 2 pi. Does everyone know how I got 2 pi? Uh-oh, why did it do that? That gives me anxiety whenever my, I'm not pushing any button. Why did it do that? Sorry guys, my laptop just did the little thingy like where something's disconnecting, but the smart board is working and everything's going on perfectly fine. So why did it give me the sound of disconnecting? Like, what the heck disconnected? Is there a hacker currently looking or what? Okay. Yeah, that scared me. Anyways, so here we go. Now I gotta subtract. What do I gotta subtract? This area here in red. So I'm gonna find the area of that integral. Area from 0 to pi, those are x values, of the curve 1 plus cosine x. Put a dx. If you forget the parentheses, that's fine. The dx is known to be like the end. Antiderivative of 1 is just x. Antiderivative of cosine, here's where a lot of people make mistakes. It's not negative sign, it is sine. There's more than one term, so I put both of them in a bracket so I won't get confused that I'm going to be doing upper minus lower of both of those terms. And now I just go upper. So let's see. Upper, so here is my upper. Pi plus sine pi. Minus, here is your lower. 0 plus sine 0. And it's a little bit of pre-cal, not extreme pre-cal, just baby pre-cal. Is there such a thing as baby pre-cal? So if we show pre-cal to a baby, does that mean they can do it? Like, here you go, baby, do it. Give it to an infant. See, okay, anyways. Sine pi is 0. Pi plus 0 is pi, so that's pi. And sine 0, 0, that's a 0, so pi minus 0. So area under this curve, I can just put an equal sign right here and just put pi there. So that's what this is. That's pi. So my area of the shaded region, so let me go ahead and be very specific to what I'm writing here. Area of shaded region is, and I'm gonna put an equal sign, 2 pi minus pi, which equals, I guess we could have gotten lucky and then just done the integral 1 plus cosine x, which was just pi, but don't count on luck. There it is, guys. Yeah, next time I'll choose a better equation. Let me go ahead and change this one out next year. Change to 2. I'm making notes. No, we can't. I mean, we can never assume. It does look like it's half, and it turned out to be perfectly half. But we should never just say, "Oh, it looks like it's half," because what if it wasn't? What if it was off by 0.000001? Yeah, that would suck. But it would no longer be half. See what I mean? All right, let's go to example 3. I'm going to change example 2 for next year. I'm going to put a better one. All right, the function f is shown to the right. So here's my function. If g is a function defined by g of x equals the integral from 5 to x of f of t dt, determine what could be said about g of -5, g prime of -5, g prime prime of -5. Okay, I see numbers for these two. The ones that I put check marks, they have exact value. I do not see this one having an exact value, but I can tell you whether it's positive or negative. So let's see. G of -5 equals the integral from 5 to -5 of f of t dt. So I go to -5 and I go to 5. Okay, what just connected? Did you guys hear that noise? Yeah, this is freaking me out. Okay, Something connected. I do not know what connected. All right. Here's what we're doing, guys. I want to observe the area between the x-axis and the curve. So I'm observing this. I'm observing all of that. You know what? I should write two different colors for positive and negative. I'm observing this. This is the area in red above the x-axis. And in green is the area below the x-axis. I actually had fun drawing that, guys. That was took me back to elementary when I would draw. Anyways, is there more red than green, or is there more green than red? I don't know, Travis. Just by looking at it, the scales are 1 and 1. The x scales by 1 and the y scales by 1. Does it look like there's more green than red, or does it look like there's more red than green?
More red.
It looks like there's more red. I wish this graph would have been like significantly more red, but that's fine. It looks like there's more red than green. If I was counting normal, if the bottom was a -5 and the up was a +5, so if I was going from, oh, and look, I already made a mistake. How come you guys didn't stop me? That's why you guys were like, I don't know. The green only goes up to here. There it is. The green only goes up to there. So now it 100% looks like there's more red than green. If the lower limit was a -5 and the upper limit was a +5, I would say this is positive, the integrand. I am counting backwards. Because you are counting backwards, this integrand has to be negative. Does everyone understand why, guys? There is 100% more red, definitely more red than green. I accidentally shaded more area of green than I should have. Now that I shaded that little piece of green, there's definitely more red than green, 100%. Cool? All right. Fundamental theorem of calculus, bless you. Fundamental theorem of calculus that we learned yesterday, g prime of x is equal to f of x. I have an x on the top, a constant on the bottom. So g prime of -5 is equal to f of -5, and I definitely have a value. I go to -5 and I look for a point on the curve, and that looks like -2. Because this graph is g prime of x, because it's the graph of f, see? And then g prime prime of x is equal to f prime of x. Well, this is the graph of f. Does it look like to you that you have a horizontal tangent at -5? Does it look like that to you? It looks like that to me. So this is 0. Does everyone understand how I got 0, guys? Okay, perfect. All right, let's continue. Godinez, you doing okay? Okay. Yeah, go ahead. Uh-huh. Uh-huh. Yes. Yes. Okay, awesome. I think you get it too, miss. We're going to find out right now. All right, next question. Capital H. All right, no big deal. So it says capital H of x is equal to the integral from 0 to x of f of t dt, where f is continuous function of domain 0 to 12, graph to the right. Okay, find h of 0. They're being basic with us. H of 0 is the integral from 0 to 0 of f of t dt. So that is just what? That is just 0. That is the most realistic face I've ever made. It reminds me of someone. Kind of looks like Mr. Winters. No, it really does if you look at it. I mean, he's just missing glasses. Well, square. Hey, Mr. Winters. Okay. Take a picture. Send it to him. All right. That looks like Mr. Wentz. It's a 0. Don't do that on the AP exam, though. Just say 0. On what intervals is H increasing? Okay, guys, the same principles still apply. H is increasing wherever the derivative is positive. That's it. So I go, first I got to state H prime of X equals F of X. I can do that because I have a variable on the top and a constant on the bottom, and that's F. So there it is. This is the graph of F, so I can just put equals H prime. So where is H prime increasing? From 0 all the way to
6.
perfect. And I'm going to write that. I'm going to write H of X is increasing. Don't write a paragraph, guys. Just write one sentence. H of X is increasing on the interval. And you can do parentheses or brackets. It doesn't really matter on this. 0 to 6. Since H prime, well, I already wrote H prime of X. That's fine. Which equals F of X is positive on this specific interval. Now, some professors are going to say you should be, like on an interval, you increase on a closed interval. So really, it should be brackets. So remember that Delta math quiz that you took, and you guys constantly were getting them wrong because you didn't know the difference between the brackets and the parentheses. Professors will tell you, and maybe other teachers as well, that you increase and decrease on an interval. So really, we should be putting brackets on this. But there will be no penalty if you interchange the brackets and parentheses. And if you're wondering why, like, but Chavez, right at 6, the derivative is 0. Yeah, but at 6 is still higher than the value at 6.01. Does that make sense? Like the y value of 6 is higher than, immediately as soon as you pass 6, 6.01 or 6.1 or 6.0001, it doesn't matter. The value of f of 6 is still bigger than the value of f of 6.0001. So by definition, you know, you increase all the way until you got to 6, and then immediately after you pass the value 6, you start decreasing. Does that make sense to everyone? So professors might tell you that. Just keep an eye out on that. No big deal. Parentheses or brackets, you'll be fine. On what interval is the graph of H concave up? That's simple, guys. All right, H prime prime of X is equal to F prime of X. I have the graph of F. So all I got to do is check where this graph what?
Is increasing?
Perfect. Yeah, that's it. We're just using our knowledge, guys. So this right here that I'm putting in red, it looks like that's a 9. So I'm going to write H is concave up. And concavity uses parentheses. Do not put brackets on concavity. H is concave up on 9 to 12 with parentheses. That has parentheses. Since H prime of X, which equals F of X, is increasing on this specific interval. There it is, guys. And this is just for notes. I'm going to put it in black. Bullet. H prime, which equals F, increasing means, you're not going to write this on the exam. This is just a definition for you guys. H prime, which equals F, increasing means H prime prime, oh, I'm trying to put H, which equals F prime, is positive. That's just for you. So put that in there. That's for you. for you. And remember, if h prime prime is positive, that means h is concave up. Okay, are we okay, guys? I think we're still good, I think. Is H12 positive or negative? Okay, that's doing the same thing, guys. We're just comparing areas. So area under the curve from 0 to 12 of f of t dt. I'm going to use the same colors that I did earlier. This is red. This is green. Is there more red than green? Or is there more green than red? What do you guys think?
More red.
Definitely more red than green. So then this has to be positive. All right, guys, when I get observed, I need more than just one of you interacting. It's okay to be wrong, guys. So just unmute yourself and be like, oh, I think it's this. As long as it's with the topic, you're good. No one's gonna judge, guys. Where does H achieve its maximum value? Okay. Where do I have a maximum at? H, not F, right? H. H continues, remember, look, H prime is positive here. So H goes up, 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 up until you hit x equals 6. Then once you hit x equals 6, then H starts going down, 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 down. It almost sounds like a song. Sorry, guys. So it starts going down all the way until you hit 12. Now, of course, we got to worry about concavity and all that good stuff, but we don't care about that. We just care about where does it go from increasing to decreasing? Well, at x equals 6. It's the only time it does that. So that means x equals 6 must be an absolute max. Does that make sense? So I'm going to write h of 6 must be it's an absolute, and I 100% know it's an absolute since this is the only location on the interval 0 to 12 where h prime is changing from, and really I should say h of 6, and here in the parentheses I'm going to put x equals 6, from positive to negative at x equals 6. Let me see if this makes sense in English. H of 6 must be an absolute max. H of 6, when I'm talking about x equals 6, must be an absolute max since this is the only location on the interval 0 to 12 where h prime is changing from positive to negative at x equals 6. I think that makes sense. It's probably not the best English sentence, but I think it makes sense. What I was trying to say is, on my entire interval, there is only one time and only one time where the derivative of h changes from positive to negative. The only time that happens is at x equals 6. Since it's the only time, I know h equals 6 must be an absolute max, whatever that y value is. Does that make sense? I think we got full credit there, guys. And we're going to practice more. Okay, let's go to example 5. And this is the last one, and then we'll talk about how we feel about this so far. The position at any time t, or the position at time t in seconds of a particle moving along a coordinate axis is s of t equals the integral 0 to t of f of x dx meters. Use the graph to the right to answer the following questions. So the graph is f of x, guys. Give a reason for your answer. All right, first question. What is the particle's velocity at t equals 5? Well, my position is integral from 0 to t of f of x. X. How do I get velocity, guys? I take a what? A derivative. Do I have a variable on the top, a t? Yes. So v of t is equal to f of t. Change the x to a t. So I go to 5. V of 5 is equal to 2. It doesn't have units. Leave it alone. Well, I guess we could put units, meters per second. Yeah, we can put units. Are we okay with that one, guys? Letter B. Is the acceleration of the particle at time t equals 5 positive or negative? Well, I know that the acceleration is equal to the derivative of velocity, which is equal to the second derivative of position. Which is f prime. Sorry. All right, what's happening at 5? This is f. At 5, is f increasing or decreasing? Uh-oh, guys. Left to right. Am I going uphill or downhill? Come on, guys. Don't be scared. Just tell me what you think.
Decreasing.
Yeah, it's decreasing, guys. It's decreasing, so that means this is negative. A of 5 must be negative since f is decreasing at t equals 5.
I have a question.
Yes.
Why wouldn't it be 0?
It is a point of inflection, but this is acceleration is just the first derivative of f prime, not the second derivative.
Okay.
Do you know what I mean or no? Because I don't feel like that answers your question. Yeah, kinda?
I don't know. It's okay.
No, it's not okay. This is velocity. So what you're looking at is the velocity graph. The slope of the velocity graph tells you your acceleration. What is the slope, the tangent slope at that point? It's not 0. The rate of change of the rate of change is 0. So if we were to find the derivative of acceleration, that would be 0. By the way, the derivative of acceleration is called a jerk. Yeah, kinda, did I answer your question or no? Okay, are you sure? You're just telling me that just so I can go on to the next question. Okay. What is the particle's position at t equals 3? Okay, that's pretty basic, guys. The particle's position at t equals 3 is s of 3 equals integral from 0 to 3 of f of x dx. So it looks like I have a linear line. So all I got to do is calculate the area of that triangle. So using geometry, 3 times 3 is 9. 9 divided by 2 is 4.5. So my position is 4.5. If you want to put units, 4.5 meters from whatever reference they started at. It's also the displacement, by the way. Okay, any questions on that? Okay. At what time during the first 9 seconds does S have its largest value? Okay, I hope that we understand this one, guys. When are you furthest to the right? Well, let's see. My velocity is positive. I'm moving right. 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 I had t equals 6. Now I'm moving left, moving left, moving left, moving left, moving left. Area under the curve tells me the distance traveled. The curve is above the x-axis, means I'm moving to the right. Curve is below the x-axis means I'm moving to the left. I am furthest right at t equals 6. S has its, okay, no apostrophe. S has its largest value at t equals 6 seconds because velocity was positive on the interval 0 to 6, meaning it was going right, and I'll put that in black parentheses, meaning, can't even spell meaning going right. Then velocity is negative. Maybe I'm writing too much, but I just trying to be specific so you guys can understand. On the interval 6 to 9, meaning moving left. And you move to the right way more than you move to the left. Look at all the area in red. This is black. Look at all the area in red. That's how much you move to the right. Does that make sense, guys? Okay. I bet you if you show Mr. Winters this question, he would really like it. Okay, here you go, Viacana. This question's for you. Approximately, when is the acceleration 0? All right, let's look at that graph, Viacana. Tell me when the acceleration is 0.
I don't know.
Yeah, you do. There's a velocity graph. This is your velocity graph. How do I get acceleration from velocity?
I don't remember.
Yes, you do. You remember. How are velocity and acceleration connected? You take a what?
Derivative?
Perfect. You take a derivative. So I'm telling you this is a velocity graph. And if I take a derivative, where does it look that my derivative is 0 for my velocity graph? It happens twice.
5 and 7.
No, it doesn't happen at 5. It does happen at 7, yes. 7, it happens for sure. At what? 4? Perfect. You see, Viacana, you do know. You're smart, miss. Don't doubt yourself. It happens at 4 and at 7, guys, because this is my velocity curve, and acceleration is the derivative of velocity. So I'm looking for horizontal tangents on my velocity curve. That happens at 4, that happens at 7. So I'm going to say I'm going to write A of t equals 0 when t equals 4 and t equals 7. And then for good notes, I'm going to put velocity graph. Velocity graph has horizontal. They're not asking to justify, but I'm giving you guys the notes here. Velocity graph has horizontal tangents at t equals 4 and t equals 7. Don't worry, guys, we're almost done. Letter F. When is the particle moving toward the origin? When is the particle moving away from the origin? Okay, I feel like we already answered that. Yeah, we did. Initially, guys, I'm at the origin. At time t equals 0, you're at the origin. At t equals 0, particle is at the origin. How do we know that? We know that because the integral starts at 0 to t of f of t dt. And if you plug in a time of 0, you get 0. 0 to 0, you haven't moved. Does that make sense? Okay. So you start right off the bat moving to the right because the velocity is positive. So we're moving to the right, moving to the right, moving to the right, moving to the right, moving to the right. If you're moving to the right, doesn't that mean you're moving away from the origin? If you've been moving to the right the whole time, it actually also, even if you move to the left the whole time, you're still moving away from the origin. So moving away from the origin, and exactly, I'm gonna write moving away, and in parentheses, I'm gonna put right, to the right. Moving away from the origin, from t equals 0 to t equals 6. And I could have written it interval notation, I just decided to spell it out. And then from 6 to 9, I'm going back to the origin, all this in green. Now the area in red is bigger than the area in green, so you don't hit the origin, you just keep going towards the origin. So moving forward, and black here I'm gonna put to the left, from the moving toward the origin, from t equals 6 to t equals 9. Yeah, if I would have started moving to the left, I would have been going away from it, but to the left. And because I stop at 6, there's more area in red than green, so I don't hit the origin between 6 and 9. So I'm still going towards the origin. Does that make sense? Guys, are we still cool? Okay. Which side? Oh, letter G is the one that I like. We think I already answered it though. On which side of the origin does the particle lie at t equals 9? Is it to the right or is it to the left? Which one is it, guys?
To the right?
Yeah, the particle is to the right of the origin at t equals 9. And then in parentheses in black, I'm going to put, that's not black, particle, let's see, particle moves to the right more than it does to the left, as evidenced by the areas. Particle moves to the right more than it does to the left, as evidenced by areas under curve. The area under the curve tells you how much you moved, guys. Okay, finally, we're almost done. We just got these 2 questions and they're calculator questions. I'm gonna show you how to do Desmos, and I don't want you to cheat, guys. Don't cheat your way. Make sure you know how to do this on a calculator, TI-84, TI-Nspire. But for now, I'm gonna do it with Desmos. So it says to evaluate 0 to 10 of 1 over 3 plus 2 sine x. Something like this, you need a calculator. Travis, why? Why can't we do it by hand? Do you know off the top of your head what sine of 10 is, or what cosine 10 is, or tan of 10? No, 10 is not a perfect number. It would have said power over 5, power over 6, power over 5, power over 6, power over 3, power over 4. Yes, yes, you can those, but not this one, guys. So go to Desmos. I'll show you what I'm going to do. And let me share Desmos. And I already forgot the equation. I don't need a graphing calculator. I just need a scientific calculator. I think the scientific calculator has it. I want it in radian mode, so there it is, radians. Go to function. Oh, because we're always working in radian in calculus. You know what, guys? The regular calculator does not have it. Let me check. Nope, I don't see it. The regular calculator does not have it. Let's go to a graphing calculator. The graphing calculator does have it because yesterday after school, we tried it out. First, we always want it in radians, and it's in radian mode. So here we go. I'm gonna click functions, and I'm gonna go to miscellaneous, and there it is, an integral symbol. I push it, it's waiting for me to push numbers, and I already forgot what I've had in the bottom. What number was in the bottom, Wadina? 0. And then I go to the top one here, and I push 10. And then I scoot, and I put a parenthesis. Let's see, it was a fraction. What do I have in the top? 3 plus 2 sine functions. Where are you? Trig sine x. Close parenthesis, move to the right, close that guy, and put dx in there. Dx. And there it is. It gives it to you. The value is 3.8019427. So write that down, guys. 3.8019. At least 3 digits every time. And I already forgot. 8019. Please make sure you know how to use this TI-84, TI Inspire. And I'm going to recommend, if you don't have a calculator yet, I really like the NumWorks calculator. I'm very impressed by it. So these are the 3 calculators I would recommend to take to the AP exam with you. If you need to know how to use them, stick around or maybe ask me after school and we can talk about how to use them. Okay, look at this question here, guys. It is a calculator question. Let f of x equals the integral from a to x, ln of 2 plus sine t dt. If f of 3 equals 4, then f of 5 equals, here's how you do it. Take a guess. What do you think this a has to be? Three. Why? Okay, I'll help you. I'll help you. Guys, put the lower limit as 3 because you're going to force this function to equal 4 when this function is 3. So now look, I test it. If I plug in a 3, do you get a 4? Well, I don't know. Let's find out. 3 to 3 of ln of 2 plus sine t. Why did I add 4? When x equals 3, what is the output of this function? That's right. Of just the function itself, without just the integrand, it's 0. But I don't want it to be 0. When x is 3, I want the output to be what? 4. So there it is. So what did I do? Why did I add 4, guys? I added 4 because I want to force this function to give me a 4 when x is 3. And notice, if I put a 3 in the top, I haven't moved. 3 to 3 of ln of all this mumbo jumbo is going to give me 0 plus 4. 0 plus 4 is 4. Does that make sense, guys? Perfect. So now, oh, it doesn't make sense to you? Okay. Ask.
Oh,
For sure.
so like that integral, that's different than the function you know it has to be before.
Perfect. So Godina said it perfectly. She said the function must equal 4 when x is 3. This function will give me all my values. This will give me all values for any x value. For any x. I made the equation. I forced myself. I forced the equation. I forced it when it was 3 to give me 4. So now, f of 5 is going to be the integral from 3 to 5 of ln 2 plus sine t dt plus whatever that is, 4. So let's go to Desmos. And I'm going to go Ready? I'm gonna go integral. Oh man. Functions, miscellaneous, integral, 3 to 5. And can you hook me up with what I had on the inside? I already forgot it. ln, where's my ln? ln of 2, was it on inside the parentheses, the argument, plus sine t. Sine x. Close like that. And close. And then I'm gonna put dx. And then whatever that is, I'm gonna put plus 4. And there it is, guys. 4.555. So I'm gonna go back. F of 5 equals 4.555. And that's it. We got it. All right, guys, let's all come back. Well, I guess you guys are already back. Let me come back.